Hi all, welcome back. In previous sessions, we had discussed about diagnostics, what is it is needed, why it is needed, and what are the standard ISO will be supported for that. And for that, we also covered UDS specification on 4229, overview of that. So UDS specification supports uh, many services. If there are maybe more than 20 up to 20, 25, 6 services are there in UDS specification. With the different services, will be achieve different diagnostic functionalities that we will be covering one by one. So today's session we are going to cover only diagnostic session control 0x10. It's a main basic foremost basic services in UDS specification. So we'll be starting. So we'll be seeing the overall agenda, the introduction, that is service description and common diagnostic sessions. What are the request and response format it supports? Session timing parameters, supported analysis. So mainly diagnostic session control. The diagnostic session control service is used to enable different diagnostic sessions in the server. So client server in a client server communication, client will request some functionality or some services from the server, and server it put a restriction for some applications. So some applications, some functionalities will be happen in one session. Some other functionalities should happen in other session, which are come with the preconditions and security access. Those things will come in different sessions. For that, session handling will be needed. So mainly service 10 we need for that session handling. A diagnostic section enables a specific set of diagnostic services or functionalities in the server. So after selecting the particular sessions which is compatible, which is required, then different services are there in UDS. We can go for reading the data identifier information from the server. We can write some information to the server, or we can have some set of functionalities specifically run on time. So that also we can perform for using a specific services. That also it enables from diagnostic session control. And there shall be always exactly one diagnostic session active in a server. A server shall always start with the default. Just whenever the program reinitializes or whenever you are starting, the first starting point will be a diagnostic uh, default session. So if you see many sub-functions it will support, we'll be covering in next slides. Diagnostic session always start from the diagnostic default session. So whenever many services are there, we can't directly go to that service to start with. So starting point will be our 0x10, which is diagnostic session control. So from here only we can select different sessions, and in different session we can have a multiple services. So that's what a server always start with the default session. Default is our foremost session. So if no other diagnostic session is started, then the default diagnostic session shall be running as long as the server is powered. So whenever we starting the server, whenever we starting the car or something, uh, the test engine will connect to the tester for debugging or something. So whenever you want to perform some actual testing or something, he can't directly see the other sessions other than default. That is what default session is, a foremost session we will be seeing. So once our powered up, it easy will be reinitialized. The first session will be default session. If you want to perform any other things, definitely we need to switch to other sessions using some default some sub functions. So if it is possible to switch between the different sessions in the server. So many sessions will be there: default session, non-default session, and programming session. We'll be covering in next slide. So switching one session to one session is possible. and it deals with the session timing parameters also. You people might have heard P2, P2 star, and S3 server. These are the timers mainly configured and handled by diagnostic session controller. So here P2 and P2 star will be covering in next slide. S3 server I'll be telling now. S3 server timing is like whenever we switch to a non-default session to a uh, default session to a non-default session. So default session will be a foremost session, and if you perform some routines testing or some programming session, we definitely need to a non-default session. So other than non-default session, we need to switch. Then we need to perform some functionality. So it is not like that. If you switch to a non-default functionality, you will be staying in that session only for a long time. There will be a restriction. For that purpose only S3 server timer come into picture. If you switch to a uh, non-default session, S3 timer will be started up to S3 server timer, which we have configured. That up to that time it will stay in that non-default session. Once the timer is lapsed, then the session will come back to a default session. So this is done by S3 server timer. It will handle the session. It takes control on a sessions. So what are the common diagnostic sessions we have? So we have overall many diagnostic sessions. First one is a default session. Subfunction is a 01. It is a normal operation, limited access. Programming session. Subfunction is a 02. Allow ECU reprogramming. And extended diagnostic session 03. So advanced diagnostics and more access. So advanced thing. So as I told, it's a default session. Some actions or some functionality will be restricted. If you go to extended diagnostic section, some advanced diagnostic functionalities can be performed. And fourth will be the fourth subfunction will be the safety system diagnostic session. So it's used rarely. So enables all diagnostic services required to support safety system related functions. Example, airbag deployment, like that. So if you consider your mobile phone for best example, if you have a mobile phone, we are operating in a normal mode. When we switch on mobile phone, all our normal functionality is enabled. Just normal calls, normal chats will be open, internet will be on. That's the default only. Like that only default session will be there. If you perform something other than if you in mobile phone only, if you put a aeroplane mode, some functionality will be restricted. You can't perform, can't access some functionalities in aeroplane mode, right? Only which are possible functionalities will be there. We can perform in a mobile phone. If you want to call, then you can't call it, right? We cannot connect to anyone on mobile in a aeroplane mode. Like that only extended diagnostic session. So if in default session, if you want to perform anything other than in flashing of the ECU, updating of the ECU, or you want to write something into a server's memory, there all comes with a restriction. We can't perform the default session. That's what we need a extended session. Then we need to switch to extended session, then perform some functionalities. So diagnostic session transition. So mainly here we can call it as a transition, also state message. As we discussed already, we have sessions. One is default session, which is very normal session. Is a foremost session when start ECU powered up, and any other session will be our default sessions. Other session will be other than non-default session. Other session will be programming session, extended diagnostic session, safety system diagnostic session. And other few sub-function will support from this UDS specification. Those are reserved for manufacturer specific, supplier specific, like that, and also reserved for future use. So if you see, this is state machine. This picture tells us clearly what is happening. See, if you see, first one is the default session, and again going back to a default session. Active session, default session, it's going back to default session. So in default session, the server shall reinitialize fault session completely. The server shall reset all activated, initiated, changed settings during the activated session. If you see any other session, if I take it as a non-default session, second one, it will jump to a default session to non-default session. Now we have more flexibility in a non-default session, so you can perform extra operations for any other diagnostic services. And in other session, what will happen when the server transition from any diagnostic session other than default session? So now default other than default session, from default to on other sessions we came. So when the server transition from any diagnostic session, so other than default session, then the server shall reinitialize the diagnostic session. So here one is we are coming from default to any other session. Here some flexibility will be enabled for us to go perform some beyond the restriction of flashing or erasing the memory. Those functionality we can done. And if came to a non-default to default, then what will happen? The session other than default session, then non-default to default, then whatever we enabled before, right, the security enabled, unlocked, and some functionality will be enabled, that will be restored, and security will be locked. The server shall reinitialize the diagnostic session. And when the server transition from any diagnostic session other than default session to another session other than default session, including the currently activated diagnostic session, then the server shall reinitialize the diagnostic session, which means that when each event which is that has been configured in the server via the response on event 86 service, that is one of service used to configure some configuration in the server. So each event which that has been configured in the server via the response on event 86. So one server is there 0x86. We'll be covering in the next session. This is one server. From this, some configuration will be done in server. So if non-default to default, if you go, whatever configuration done from 86, that will be restored. Which means that each event that has been configured in the server, using this service shall be stopped, and security shall be relocked. All other active diagnostic functionality that is supported in the new session and is not dependent on any security access shall be maintained. That will be maintained. Then we are going back non-default to default and non-default to default. So now here three will be one will be default to default only, second will be default to non-default, and three will be in the same session. If you are activated in the same session, again reiterate to that session, it will be perform some action. Again ECU initialized to reinitialized, then some function will be stopped. If you switch to same session, suppose if I see sub function 03 I have, then again requested 03, no, whatever previously we enabled, that again locked, and again if I using requested same sub function also, then some functions which were opened last session, that will be terminated. Then again we need to request for that functionalities. And if you go to default, then in default, what will happen? Default session, when the server transition from any diagnostic session other than default session to the default session, then the server shall stop each event that has been configured in the server. Any other active diagnostic functionality that is not supported in the default session shall be terminated. Now we have enabled some functionality here. When we move to default session, those all functionalities will be terminated. Now this is pure default session, beginning of the session. Then if you want to perform anything, any extra function which required a precondition or something or security access, Then again you need to switch back to non-default session and perform your activity. And we have a request and response format here. If you want to request some functionality, it is provides some UDS specification provides the particular way. In that way only we need to request. So first byte will be a diagnostic session control SID, that is 0x10. Then second byte will be subfunction, that is subfunction type, means it will support 00 to 0FF. Subfunction will be 01, 02 programming session, 03 extended session. Whatever subfunctions we discuss now, that will come into a second byte. So first we need request 10. After that, whatever subfunction you want, that will be there in the request message. Then you can send to a server. Then how we will receive the response message? The response message, it looks like this. First byte will be a diagnostic session control SID plus 40. 40 will be added. Then it will come to 50. 50 means positive response. Whatever I requested, server is done and the task has been done, and server giving the positive response for me. That is 50. Next again second byte, it will be a 000F supported, means whatever subfunction I have requested, right? Same subfunction it will show here. If I requested 10.01, then in response I'll be getting 50.01. This is response message. And third byte, from third byte will be having some information regarding P2 server and P2 server. P2 and P2 star we already discussed. We discussed what is it, whatever frame we are receiving, right, in the response. First byte will be a 50 positive response, then followed by default session, and followed 2 bytes allocated for P2 and P2 server. So P2 and P2 server will be discussing next slide. What is that? So suppose P2 star. First we'll discuss the P2. What is the P2 timing and P2 start timing? It is very important for to get a correct functionality with a specified time. So here we have a tester, and here we have a server. So what I'll just request some functionality to the server. Suppose I requested 10.01 subfunction 01. So now I have already sent a request. Then now that is server's issues responsibility to send a post response. Like it should send a response, whether it may be positive or negative or any other pending request. We should receive that within the specified time. So one timer will be there. Within that particular time, I should receive a response from the server. That particular time, right? We'll call it as P2 timing. So we received. Suppose if you P2 there, if we have received some, we didn't receive any positive response or negative response. We received suppose pending response. If you receive pending response, so how long you will be receiving pending response? There will be some timing, right? For that we'll have a P2 star. So what we'll do? I have sent a request to a server, and server process it, and it is telling, hey, wait, I need some time. So I'm still processing. That time P2 timing already lapsed. Then it will send a pending response NRC 78. From that NRC 78 will be receive multiple NRC 78 up to a P2 star timing configured timing. So till that some timing will be started. Till that timing we will be receiving this NRC 78. So once it is lapsed, that timing we will be calling as P2 star. So generally once that P2 star also lapsed, then server maybe throw a general reject for that particular request. This is what P2 and P2 star timing parameters. And overall, from pictorial representation, first I'll send a tester request. Then ECU tells, wait, I need some timing for processing. Now I'm sending a NRC 78. From request, after that, after some time, I'll receive a response. That particular time we used to call as a P2 star. After 78, P2 star timing configured continuously, we will receive NRC 78. So till that timing, we'll call as P2 star. So this is a P2 and P2 star. Hope it's clear. If not, then please um, rewind the video and watch it again. So I want to show the overall request and response, how exactly we will be getting. So 7E0 is a CAN ID for a powertrain. This is a request message I'm showing. So 7E0, then 02 is a PCA. What is the length we need to mention? Then I'm sending 1001. This is 1001 is a default session. So server get to know. So I'm requesting for default session. Then it will perform the process and send the positive response back. Then positive response will be having this 7E8. 7E8 is for receive. 7E0 for transmit and 7E8 for reception. So that is 7E8 CAN ID, RX CAN ID for powertrain. And we need to mention what is the PCI length. PCI length is a 6 because 1, 2, 3, 4, 5, 6. 6 bytes information we are incorporated in one frame. 06 and 50 is a positive response for default session, subfunction 0 and default session. 0032 is P2 timing. 01F4 is a P2 star timing. We already discussed what is P2 and P2 star. Whatever you are getting, suppose 0032 is a hex, 0032 is a decimal 50, means 50 millisecond if you consider. This again it's depend on project or OEM. Project specific configuration will be there. If you configure 50 millisecond, then 00332 decimal is a 50, then it's a 50 millisecond. 01F4 is a 500 into some resolution. If you see 5 millisecond will come. So 5 millisecond is the P2 star. The P2 star are configurable and that depends on project. Just I wanted to show how the CAN frame looks like. This is for default session. Same way we can request for extended diagnostic session. So request for to start the session 3 in extended diagnostic session. Same way I am sending 0 to PCI length, 1003 is for extended session. So what I'll get 5003 followed by same P2 star information. I hope P2 star and message request and response format is clear. So we'll be moving to next slide. So if you see P2 and P2 star, P2 is a P2. It has a 2 bytes information and resolution of 1 millisecond, and minimum value is 0 millisecond and maximum value is 65535 milliseconds. P2 star, it has also a 2 bytes, but it has having the resolution of 10 millisecond and the minimum value 0 millisecond and the maximum value is 655,350 milliseconds. So next, supported negative response codes. So whenever we requested some functionality to the server, either we can get positive response or we can get negative response. So definitely negative response is very important, so that we come to know what went wrong and what is a possible error happened in the server, so that we get to know what is the cause of that. Then we can correct it and send the request back. So now supported NRCs for diagnostic session control are 0x12. This subfunction not supported. So suppose suppose diagnostic session control supports 10.0.1, 0.1 and 0.2, 0.3. These, for example, these subfunction will be supported. So in case if I send 10 and 11, 11 is not supported, right? It will throw a server will come to know this is not supported, so it will throw 0.12. So how will get response? 7f 7f is a code for NRC 7f. Then whatever we requested, 10.0.11 we requested it. 10 it will consider for diagnostic session control. Now it will throw 7f 10 and it will send NRC. This is 12. So the moment if you get 7f 10 12, we come to know. So okay, we requested for 10 11 diagnostic session control. Um, so we received a negative response, that is 7 of 10 12. 12 is the meaning of subfunction not supported. We come to know subfunction is not supported for the current specification. So we can correct it. Then we can request whatever supported subfunctions. Then server gives a proper positive response. Next, 0x13 incorrect message length format. So this NRC shall be sent if the length of the message is wrong. So here what suppose if I sending 10.0.1 is this request for default session. Instead of that 10.0.1 0.1 if I send, it will not support 3 bytes, right? 3 byte request. Only it will support only 2 bytes request. If I send extra byte, then it will throw NRC 13. Next, NRC 22. Condition not correct. This NRC shall be returned if the criteria of the request diagnostic session control are not met. Some preconditions will be there. If I without meeting the precondition, if I went for requesting some services or some functionality, then directly server will throw NRC 22. Condition not correct. We need to correct that precondition. Again, we go for requesting the functionality. Then it will throw a correct message. I hope this is clear. If anything is needed, please do comment in the comment section so that we'll come with um, any clarity. And if anything is want to add something, then you